Good morning. The subject of this talk is product development with the Atmel 328P chipset. The Atmel 328P is the dual inline chip used in the Arduino Uno. The Arduino logo is a trademark of Arduino AG and can only be used by Arduino on products, websites, and publications. However, Arduino does permit us to use the Arduino open source community logo, which is pictured on this screen. I have been successful at developing boards using the Atmel 328P or the Uno, and I have been able to take my designs all the way from implementation on an Uno to a printed circuit board. There's a lot of reasons why I like using Arduino. The IDE from Arduino.cc is easy to use, it's free. It's open source electronics. You can easily prototype using the Uno or one of the other Arduino products, and then you can take your circuit off board. There's a lot you need to know, but there's a lot of help out there on the web. And from that point, drawing the schematic and ordering a printed circuit board is easy. It's a lot like any other chipset, except the road online's a lot easier. It's a lot easier to offer people support with everything the Arduino community has out there. Okay, what's the goal? Create a circuit that we need, prototype the circuit, consider our design considerations, and produce several copies of that circuit by creating a printed circuit board using one of the online vendors. We want to document the circuit with a schematic, and we want to program create a sketch for that circuit, adding libraries for our new shield. My particular goal has been to create an LCD display board. You can find more information about that on my other videos. However, I'll quickly put the board in front of the screen so you can see what it is. This is the LCD display board. I will cover that in another video. What I learned about prototyping boards using the Atmel 328P was that you didn't want to bend the pins when you took the chip off the board. There's documentation online about removing the chip from the Uno board and putting it on a breadboard or using it in a circuit. There's a lot of pictures of chips, of blank shields, of capacitors. Once you get off board, you need your own power supply, and you might need a 3.3 volt regulator as well. But I have a couple slides which demonstrate going off board. Here's a picture of a genuine Arduino Uno, not a clone, with the chip removed. You can see the chip is in the jaws of the pliers, and that the socket is missing the chip because it's been removed. I've put a penny in the picture so you can see what size, the scale of everything. Once we've prototyped a circuit on the board and we want to go off board. 2 of 13. The circuit's on the board and we want to go off board. There's 3 of 13. We created again to reiterate, we used the Arduino Uno to build a program. The program required power, ground, and 2 data lines, digital lines. It worked. We want to go off board. There's a breadboard. I need to make a video on how a breadboard works, but it's essentially a electronic plug board which allows wires to be connected without solder. We use a screwdriver and, with the power off, carefully remove the chip from the board. and then we put the chip in the breadboard. Then it helps to refer to the Creative Commons diagram. That's the open source license that has a nice diagram of the Atmel 328P and the Uno. Using this diagram, we can know what pins correspond to pins that came out on the Uno. Now I've plugged in the crystal and the power. I've got the capacitors, and I've got the blinking light that I wanted to have for the sketch. I think I put the chip in backwards, so I'm reversing the orientation of the chip. There's the completed circuit off the Uno on the breadboard. And now it's powered up and the light is blinking. When you go off board, there's three things you really have to provide: clock, power, and USB. Clock is represented by the crystal. Power is the 5 volts required to power the Arduino. And USB helps you program the Atmel 328P chip. It helps to use a breadboard to test your circuits. Even though you've tested the circuit on the Uno, it's good to wire it up on a breadboard and test it on the breadboard with just the chip before you go further with your designs. There's a power regulator on the Uno, but how much power can it source? I don't know the answer to that, probably not that much. I also found that sometimes the breadboard had enough stray capacitance that I didn't need to put capacitors on the crystal that creates a 16 megahertz clock for the Uno. Placement of the crystal and the 22 picofarad capacitors is very important. 16 megahertz is a pretty fast frequency. It's a lot fast. It's 16 times faster than the 6800s I started out with. And then when you're all done, you test using blink. On board, that would be pin 13, or off, pin 13 to an LED through a resistor. When you're going off board, you need USB. You'll want to reprogram the chip. You don't want to constantly put it back in the Uno without a zero force insertion socket. So you might want to use an FTDI card like these available at SparkFun or some of the other vendors with an RT232RL chip on it. This chip takes USB and converts it to serial transmit receive so you can reprogram your Uno design. And then we get the prototype to work. So there's a lot of computers out there. And the reason I like Arduino is you don't need an operating system for it. That's something I left out earlier in this talk. There's other chipsets that you can use, such as Texas Instruments MSP430, that really make a nice standalone single usage computer. But these techniques would be also valid for building a custom hat for the Raspberry Pi. I haven't done a lot with Raspberry Pi. I have built kernels. Okay, catching the bus. I love this slide. There's a lot of programming buses you need to master. And they can be tricky. I2C, interprocess communication, SPI, serial, well, I won't make that up, and Dallas one wire. There's a lot of lists, and there's a lot of bits. Here's a breadboard of mine. This is a USB breadboard. It's a USB receiver, and when you plug in USB at the top left of the screen, the Uno receives the USB signal and tells you what's in the data stream. I cannot wait to have the time to work on this circuit more. On the screen, I have the circuit off the board. The Uno's on the board. I've not yet moved the Uno to this breadboard. There's no crystal on the board, but there's a power supply, there's a regulator, the sample circuit itself, and of course the Uno on the Uno board. After you get a little further, you can draw a schematic. So I'll be drawing some schematics for that USB project. KiCad's what I use. It's open source software. I was able to install it on Windows and Linux. I was able to build it from source on Linux. The next steps are to build a prototype or two and design and order a printed circuit board. And I did try to build these at home, etch these at home at one point with an acid bath. When I did that when I was much younger, it didn't completely etch, and I had to scrape the copper area off. Now it's just too dangerous, I feel, to use acid in the house like that. So I ordered out. I ordered out from 2 Chinese vendors, and now I'll be ordering from an American vendor. This is one of my prototypes. Now this is called a daughter board. This is the daughter board for an LCD display shield. It has a header with 40 pins that go to an LCD screen, and it plugs into the Uno. I built this because I needed a way to have the Uno run one of these LCD screens. Once the circuit worked, I was able to go further. I drew up a schematic, and I finished a printed circuit board. That's a lot of steps all in 2 slides. But if you don't take, step 1 was to take the Uno off the board and try your circuit on a breadboard. So not to worry. And then I created a finished printed circuit board of the LCD display board. And there it is. It has 2 Atmel 328P chips on board and a header for the LCD screen. Surface mount technology is hard to deal with. I like the Uno because it has the dual inline pin Arduino Atmel 328 chip. I haven't mentioned this before in the talk. That's 0.1 inch separated pins that are far enough apart that you can solder them. That is 1/10 of an inch apart. These pins here are half of a 1/10 of an inch, very close together, and hard to solder by hand without some tricks which I learned. When I first created my design and sent it out, it came back with a lot of mistakes. I had to send it out again. This time I have only 5 mistakes, and it doesn't prevent me from moving forward with my board. That's my final board with the LCD screen on it. You can just about see a clock that I've programmed. It has a power supply, a battery connection, and Bluetooth on this board. Once you get going with Arduino, there's a lot more that you may not be aware of besides digital lines that blink lights. There's interrupts, there's timers, there's pulse width modulation, and I've discovered even more things on this simple chip. And I don't know what the lifetime of this chip is. I saw a reference that said Atmel 328P may have been superseded by Atmel 328PB. I don't know if that means the dual inline version has been superseded or they still have a new version of that out. Probably you can still use the dual inline version for some time to come. And that's it. Keep it going. Thank you. My name's Evan Williams. My company is Evan Williams Consulting. I'm at evanwilliamsconsulting.com, and the slides are online on SlideShare.